Geotrig outline lesson 20. Today we're actually going to talk about more some of that trig stuff. So for the most part, for most of us, this is going to be brand new. We've used trig before. Sine, cosine, tangent, SOHCAHTOA. Right? And we've found values or ratios given an angle of a triangle, or we've gone the other way, we're given some sides of a triangle, and then we found an angle. So today we're going to focus on two special triangles, but before we start that, it says, when can we actually use sine, cosine, and tangent? It only works on certain things. When does it only work? On right triangles. It only works on right triangles. Again, to either find an angle or to find sides, given one of the sides. Remember, when we use or set up that ratio, and we might as well write it down here, each one of these stands for the different ratio, or the different function and its ratio. Like sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, correct? So each one of these sets up a trio of information. You either know the angle that goes into the function, or you know one of the sides, or you know the two sides so you can find the angle. So if you have two pieces of information, you can find the third very easily. And it says out here that most of the time, you guys have probably used your calculator anytime it came up with a sine, cosine, or tangent problem. Most of the time you do. But there are some cases, and we're going to actually force those cases upon you, where you actually can determine the values of those sine, cosines, and tangents without. And those angles are of 30 degrees, 45 degrees, and 60 degrees. There's also forms of, well, actually 90 would be included in there, but 90 is made up of 30, or the 60s as well. So anytime in this lesson, we're going to talk about an angle of 30 degrees, of 45 degrees, or 60 degrees. You're not allowed to use your calculator anymore. It actually will take you longer to use your calculator versus what we're going to do today. And this will go for any angle that's a multiple of 30, 45, or 60. So what are those two special cases? They're made up of two triangles. One of the triangles is this one. And these triangles are called reference triangles. The first one is called a 45, 45, 90 triangle. And I will always, 95% of the time, create my reference triangles the exact same way. I will most likely put the 90 in the bottom left-hand corner and put 45 and 45. We know that if we knew one 45-degree angle, the other one has to be 45 because they have to add up to what? All of them have to add up to 180, or the two other angles have to add up to 90 because 90's already been taken off. And here's the cool thing. Each side is a 1, and the hypotenuse is a square root of 2. And so, this is how I set mine up if I was going to quickly draw it. I draw a right triangle, and I go 1, 1, 2, and then I think, wait a minute, the largest number is always going to get a square root. And that's why I know what it's going to be. So on the very bottom there in the blue, I made a reference triangle very quickly, not drawn to scale, but now I have it. And I'm actually able to find sine, cosine, and tangent of any 45-degree angle. We're going to go into that in a second. Because if you think about it, Well, actually, we'll do it now. If you think about it, if I ask you for the sine, cosine or tangent here. And if I ask you for the sine, what is sine again? Opposite over hypotenuse. Okay, here's 45-degree angle. We'll start here. Let me take some extra lines out of here. If I ask you for the sine of 45 degrees, well, here's a 45-degree angle at the bottom right of that first triangle, correct? Opposite is 1. Over hypotenuse, square root of 2. So what is the sine of 45? 1 over the square root of 2. That's the exact value. Now, a lot of the times, as we're working through this, you're not going to like that. We won't like 1 over the square root of 2. Why? Why are we not going to like 1 over the square root of 2? Well, it's not going to be a nice number because we have a square root of a not-so-nice thing. But in general, I wouldn't leave it in this form either. I wouldn't leave it as 1 over the square root of 2 because what don't we like about it? Square root on the bottom. So to fix that, 99% of the time, we multiply the top and bottom by square root of 2. And so you end up saying, hey, 1 times the square root of 2 is square root of 2. And square root of 2 times square root of 2 is just 2. So 99% of the time, we will always just write that sine of 45 is the square root of 2 over 2. Now, if you happen to take your calculator out, which is probably good practice to at least check yourself, what would, if make sure you're in degrees, what is the sine of 45? This is not the answer that I want to see. I want to see square root of 2 over 2. I don't want to see what you're going to write down here after it, but it's good at least to know what the approximations are. Like 0.7, is it 0.707? Yeah. So it's about approximately 0.707. Take square root of 2 and divide it by 2 once. Square root of 2 is about 1.73, so if you divide that by 2, you get approximately 0.707. They are equivalent, okay? It works out really cool that way. Now wait. Just for fun, what's the cosine of 45 degrees? Looking at your triangle real quick. Using the same cosine that we have circled there. Cosine is adjacent over hypotenuse. What's the adjacent? So it ends up being 1 over a hypotenuse, square root of 2, which is square root of 2 over 2. Notice that sine and cosine of 45 degrees is the same. And just for more fun, what's the tangent of 45? Tangent is opposite over adjacent, which ends up leading you to 1 over 1, which is 1. Test these things out on your calculator. Just don't take me for granted that I said this. Does tangent of 45 equal 1? Yes, it does. Okay? If you can remember that triangle, you will have any form of 45-degree angle. Sine, cosine, tangent, you'll have it. Easily done without having to take your calculator out. Eventually, you guys will remember that. Because sine and cosine are the same. You just have to remember square root of 2 over 2. Sine of 45? Square root of 2 over 2. Cosine of 45? Square root of 2 over 2. It's just going to come natural. It's going to come quick. It's going to seem awkward this year, I think, but when you guys get to pre-calc next year, you guys will have to do all of this again. Be assumed that you know it, and you have to use it. It'll come faster. It'll be easier. You guys will be like, oh, this is actually really easy. For some reason, because this is the first time you guys are seeing this probably, it does take a little bit of time. Okay, now, the triangle here on the right is the exact same triangle I copied and pasted, but I changed it. I didn't call it 1 on the bottom, I called it X. So what we're actually going to be able to do is that we might be able to manipulate a triangle that we know is a 45, 45, 90 triangle. And we are actually going to be able to find all the sides really easily using the same idea that there's a ratio. Now, on the top there it says, what's the ratio of those sides? Well, if I'm talking about 45, 45, 90, we should probably talk about the sides opposite those angles. Both the 45s, if you're looking at the left triangle, have a ratio of what? What's the side lengths? Opposite each 45. It's 1. And then another 1. And what's opposite the 90? Square root of 2. So it's 1, 1, square root of 2. Those are my side ratios. Now wait a minute. What if I go to that right triangle and I call that bottom side an X? What's the other side? X, because it has to be the same. They're the same. What do you think the hypotenuse is? Square root of 2. Sorry, that should be a 2. Square root of 2x. Correct. So, the ratio is still there. It's still 1x, square root of 2x. So, I'm going to go and change my ratio already underneath, so you guys don't have to erase anything. X, square root of 2x. So if you recognize that you have a 45-degree triangle, and you know one of the sides, you know all of the sides. Because all you have to do is copy one of the sides, it's x, and the other one just multiply by square root of 2. I have an example of that coming up. Before we get into examples, we're going to do the exact same thing here, now with the 30, 60, 90 triangle. This is lesson 20, yes. Look at the triangle there. I have a 30-degree angle, 60-degree angle, and I forgot to put in 90s, because they have to be right triangles. Okay? The same idea applies. Now this is cool because it helps me find any of the 3 trig functions for 30 and 60. Now, you're going to find that I will draw this particular triangle, because the other one's not so bad. 45, 45, 90, you can't mess it up if you remember that the side lengths are 1, so that means the hypotenuse has to be square root of 2. This one, though, people can get it mixed up, because the 30 and the 60 can swap places, right? I could draw it differently. The ratios would still have to be there. And so, my biggest suggestion, because every time you're going to see me draw it, you're going to see me draw it in the exact same form as it is now on the left. I will create a right triangle, and I will always put 30 on the top, 60 on the side, so I can do this. 1, 2 for a hypotenuse, 3 for the side. 1, 2, 3. And then I always say the largest number takes the square root. So therefore, I can just do 1, 2, 3, square root. That gives me the same triangle as the left. And then, once I have that triangle drawn on my paper, on my quiz, in my homework, I can turn it. I can flip it, because now I have my sides and my angles all in the right places. Nothing says that you can't put a 60 on top and a 30 on the bottom as the angles. But you better have your 1 and the square root of 3 moved. But if you keep things consistent, and at least in the very beginning, you can change it, you can rotate it, flip it, and you'll have everything in the right place. Okay? You guys get what I'm saying? Keep it simple. Do it the same way every time, then you can change. Now, before we move on to that right triangle again, please tell me what the sine of 30 is, please. You're right now thinking, well, what was that ratio again? You better write what also on your paper right now? You better be writing the SOHCAHTOA on your paper? No. It's 1 over 2. It becomes 1 over 2 because sine is opposite over hypotenuse. And opposite 30 is 1. The hypotenuse is 2. What is the sine of 60? And eventually you guys will remember these. Sine of 60 is square root of 3 over 2. What's the cosine of 30? You seeing that once you have this written down, I think it's faster than trying to type it on your calculator. Cosine of 30, cosine is adjacent over hypotenuse. Square root of 3 over 2. What is the cosine of 60? No. Cosine adjacent is 1, hypotenuse is 2. So therefore it's 1 over the square root of 2. Or 1 over 2, sorry. My bad. Wait a minute. Any connection there? Yeah, that's weird. The sine of 30 is 1/2, but the cosine of 60 is 1/2? Annabelle? We can do tangent. Let's do tangent of 60. Which is, tangent is opposite over adjacent. Square root of 3 over 1. Now, just like we did before, if I called that bottom side x on the right triangle, that means the hypotenuse would be 2x. The side that's missing we will call square root of 3x. So as soon as I tell you a value of x, you can finish all 3 sides just by knowing that ratio. Because that ratio will always be the same for a 30, 60, 90 triangle. So if I go to the top, we have 30, 60, 90. So I'm going to keep it in that order. Opposite the 30 is 1. Opposite the 60 is square root of 3. 2, correct? I'm following the order of the sides opposite those angles. And so if I changed it and I called it x, then the next one would be square root of 3x and 2x. That's my side ratios. Going in order from 30, 60, 90. And again, I have an example that's going to allow us to do this very quickly once you recognize if you have a 30, 60, 90 triangle or a 45, 45, 90 triangle. If you know those sides and those ratios, you're good to go. This is what I was talking about the example. It says find x and y using that special triangle relationship that we talked about. Notice you got a 90 and a 30. What kind of triangle is this?
30-60.
It's a 30, 60, 90 triangle. That should be a given. That should be a 60. It's obvious. Now, what you need to see here is that because I see the relationship that this is a 30, 60, 90 triangle, which is a special triangle, And notice opposite the 60 should be the square root of 3. Yes?
Yep.
If you remember back, let's draw that out. There should be 30 on top, 60 here, and 1, 2, 3, square root. Boom. I draw that exact same one every single time. That should be a 90. Every single time in that order, and you can say, hey, that's not the same orientation as I have on the left. But if I take the paper and slide it sideways, it should be. Or it will be. And so you know that you have that ratio of 1, 2, square root of 3. And remember, that 1, 2, square root of 3 is really x, 2x, and square root of 3x. So the question is, are you able to find the number, or that ratio number that's going to be applied here? What's the difference between our ratio and the number that's given? We have a square root of 3. What's the extra number?
4.
4. So what's x? 4. And notice that x is the actual x in the problem as well. So now you know x is 4. I'm comparing these two up here.
X is the extra number.
You notice the big circle there?
Why did you write them in?
I wrote my ratios, my side ratios that we talked about for a 30, 60, 90 triangle.
How did you get x equals 4? Just because you multiply this.
It's the extra. It's the
Okay.
extra number.
These two numbers in the circle there have to be the same.
Okay.
So that means x has to equal
Whatever else.
4, right? Because 4 times the square root of 3 is square root of 3 times what? What does x have to be to make it 4 square root of 3? 4. And that x corresponds with this x here, which happens to be the x I'm trying to solve for, which is why I said it's 4. Y happens to be 2x. If x is 4, then y has to equal 8. Now, guys, this is a right triangle. If you are going to say x is 4, then I could use Pythagoras' theorem to solve for y. That's an option as well. But I think it's a lot easier to say, wait a minute, there's a common ratio going throughout this whole thing. Use it to your advantage. Your homework is lesson 20, page 148, 1 and 16. Have a great day.